Welcome back, everyone. We're going to conclude this chapter by talking about the scope of inference that we can make from a statistical study and talk about what statistically significant means. So to begin, what I would like you to do is go to this page right here and read this portion all the way down to the table down here. So pause your video for a moment, do that, and we'll be right back. So I want to remind you, we take samples or we collect data from samples and we use that information to make inferences about populations. How we collect the data from those samples determines what kind of inference we can make. So for example, if the sample was randomly selected from the population, then we can make inferences about the population. If those subjects were randomly selected from the population and they were also randomly assigned to groups like a control and a treatment group in an experiment, then we can also make inferences about cause and effect. So if both of those statements are true, the subjects were randomly selected and randomly assigned to treatment groups in an experiment, then we could make inferences about the population and inferences about cause and effect. If they were randomly selected but were not randomly assigned to treatment groups, then we could make inferences about the population, but we could not establish a cause and effect relationship. If, on the other hand, the subjects were not randomly selected from the population, let's say they were volunteers, but they were still randomly assigned to control and treatment groups, you couldn't make inferences about the population, but you could establish cause and effect. And the reason being that maybe those volunteers are not a good representation of the population, even though we found a cause and effect relationship. And if neither one of those things are true, the subjects were not randomly selected and they were not randomly assigned to treatment groups, then you cannot make inferences about the population, and you also cannot establish a cause and effect relationship. So to make sure that you understand this idea, I would like you to read number 1 here, go through all 4 designs and determine what kind of inferences can be made. Can inferences be made about the population? Can inferences be made establishing cause and effect? Pause the video now, do that, and then check your answers below in OneNote. If you have any questions on those 4 designs, make sure that you ask about those during class. Right now, I would like you to read this highlighted paragraph here, read questions 2 and 3, and provide answers for those. So go ahead and pause the video and do that, and then we will come back in a moment to discuss some conclusions here. So at this point, you might be asking yourself, well, how do we make any sort of cause and effect conclusions, particularly for humans, if the only way to do that for the entire population is to randomly select them and then impose treatments on them, which is clearly highly unethical? So there are some ways around that, and the good example of that is the cause and effect conclusion that's been made between smoking and lung cancer. We're going to talk about that in just a moment, but I just want everybody to know the issue of ethics is not part of the AP curriculum. So even though we might touch on that occasionally, it's not something that you have to be familiar with. So, as you are probably aware, the Surgeon General has determined that smoking causes lung cancer. I believe in Canada they put on their packs of cigarettes something like, "Smoking kills you." How did they do that if they weren't allowed to randomly select subjects from the population, randomly assign them to a smoking group or a non-smoking group, and then see that there was a strong association between people that smoked and lung cancer and those that didn't smoke and not having lung cancer. So how do they do that? Here's how they do that. They figure out that the association is strong, like the one between smoking and lung cancer. They determine that the association is consistent. They see this pattern many, many times with many groups of people. And in this case, they've actually seen it with animals as well. They see that large values of the explanatory variable are associated with stronger responses. So in other words, people that smoked more tended to have earlier lung cancer or have worse lung cancer. They determine that the cause comes before the effect in time, which they did with smoking and lung cancer. They found that people that were dying from lung cancer in large numbers also smoked before they developed lung cancer. And then lastly, the alleged cause is plausible. And this is where experiments with animals showed that was the case. Animals that were exposed to the tar from cigarettes ended up with lung cancer. So, again, ethics is not part of what we cover in the AP curriculum, but I thought some people might be raising the question about, well, how did we establish some of these cause and effects without being able to do experiments? And this is an explanation of that. So I want to finish up the chapter by looking at this particular case study and trying to connect it back to all the things that we've talked about, particularly with experimental design. So early research showed that magnetic fields affected living tissues in humans. Some doctors have begun to use magnets to treat patients with chronic pain. Scientists wondered whether this type of therapy really worked. They designed a study to find out. 50 patients with chronic pain were recruited for the study. A doctor identified a painful area on each patient and asked him or her to rate the pain on a scale from 0, mild pain, to 10, severe pain. Then the doctor selected a sealed envelope containing a magnet from a box that contained both active and inactive magnets. That way, neither the doctor nor the patient knew which type of magnet was being used. The chosen magnet was applied to the site of the pain for 45 minutes. After the, quote, treatment, each patient was again asked to rate the level of pain from 0 to 10. 29 patients were given active magnets and 21 patients received inactive magnets. All but one of the patients rated their initial pain as an 8, 9, or 10. Because their initial pain ratings were so similar, scientists decided to focus on patients' final pain ratings. Here they are grouped by the type of magnet used. Discuss the design of this experiment and comment on the conclusions you might draw from the data. So I'm going to go into a rather extensive discussion of this experiment just to try and hit on all the things that we've talked about in experimental design. First of all, this is a completely randomized, double-blind experiment. By completely randomized, we mean that we had no blocking. Double-blind, why is it double-blind? Because the subjects were given either an active magnet or a placebo inactive magnet, so they did not know what treatment they received. But also the people involved with assigning the treatment, or not assigning the treatments, but applying the treatments, did not know what kind of treatment the subjects received. The experimental units, the smallest unit to which the treatments could be applied, were the individual subjects in the experiment. The design makes use of all 4 experimental design principles. It makes use of control by using a placebo. It makes use of control because all the subjects had similar initial pain ratings, so that's a form of direct control, as is a placebo. It used double blinding to control for the placebo effect. And it used random assignment to try and balance out all of those things that are outside of the experimenter's control prior to applying the treatment. It used randomization. the treatments were randomly assigned to the subjects, or the subjects randomly assigned to the treatments. It used replication. Each treatment was applied to numerous experimental units, which were the subjects. It used comparison. The difference in the average pain scores after treatment were compared, and if you check that out, it turns out that the difference in the averages was 4.14. So, based on the design of this experiment and the results, which I will assume are statistically significant, it would be reasonable to conclude there is a cause and effect relationship between using an active magnet and reducing pain. So what do we mean by statistically significant in this case? What we mean is that the difference in the average pain ratings is unlikely just to happen by chance. In other words, if the magnet had no effect whatsoever on reducing pain, because of random assignment, it could turn out that the difference in the average pain ratings could be 4.14. What we're saying is, if these results are statistically significant, that outcome is so unlikely to happen by chance assignment, so to speak, that it's more likely due to the application of the magnets. So this concludes the videos for Chapter 4. Hopefully you enjoyed Chapter 4, and hopefully you've gotten a lot out of it.